All right, we are continuing on with Numpy, and there are three main topics that I want to cover today. So the first one is Numpy Nan, the second one is concatenating and stacking arrays, and then the third one is interpolation. So Nan, Numpy Nan, so the first thing that we are covering today. So Nan is short for not a number. So this is a concept outside of Numpy, outside of Python. So there's actually, definitions of what Nan actually is. And so what we're covering is Numpy's version of that. So it is used to represent entries that are undefined. So you might encounter this, for example, if you divide by 0, and if you divide by 0, you create an undefined value. It is also very commonly used for representing missing values in a data set. So sometimes when you collect data, there might be errors that occur that prevent you from collecting data. So for example, your sensor might fail either fully or partially, and so you're missing some data from a given observation. Or maybe you were sick one day, so maybe you're a field ecologist and you were sick one day and you failed to make observations in the field. So in this case, you want to have a number that represents an incomplete value, and so this is where Nan is very useful. You also might want to make post hoc analysis of your data set and want to indicate that the data you collected is incorrect. So for example, maybe you made a field observation of the number of mice that are observed in a particular location, or perhaps like a number of fish that are observed in a particular location. But after you make that observation, you find out that there was a large number of boats or other people in the area that disturbed the mice. And so you probably want to mask out this data, filter out this data, because it's improper. It's improper to include it in the normal data set because there was external factors that caused it to be poor data. So numpy.nan is our version of that. So let's import numpy, start Python, and looks like I lost my version of numpy on here, so I will install it really quickly. And so there is an object that is defined in numpy called nan. And so this is a float type object. So it is a number. And if we do the type, we see it as a float type object. So one thing to know about this is you cannot use integers. So you cannot use numpy nan in integer type arrays because the integer type does not support numpy.nan. There is no integer version of numpy.nan. So let's see what this means. So let's create an array of integers, and we can verify this is an integer object array. And if we try to, for example, change one of these arrays, we can always change it using the slicing operator, but if we want to change it to a numpy.nan value, we get this value error because you cannot convert the float nan to an integer. So let's see how we might use this. So now we have an array of data that ranges from -30 to 16. And a common criteria is that you want to mask out data if it violates some sort of threshold value. So if the value is below 0 or it's greater than 5, then we might want to mask it out as an outlier. And so you can do that very simply by using the filtering to grab all of the data in the array that violates this thresholding. So this first comparison says if it's less than 0, so -3 and -30 are the two elements that are less than 0, and then I can use this OR comparison And then my second conditional is if a greater than 5. And so that's why the 16 gets pulled out. So I've identified all of the elements in the array that violate this thresholding, and I can simply set them equal to Numpy Nan. So now I have an array that has both its normal values, and then we've masked out the data that we think is bad because it violates this threshold. So let's say we want to find all of the values in the array that are equal to Nan. So, you can always do something like this in Numpy. So if we use a comparison, it says find all of the elements that are equal to 1. And so you can see that there are two elements in the array that are true, and that's how we can find which elements are equal to 1. So we might think that we can also do this using Numpy Nan. So if I want to find all of the elements that are equal to Numpy Nan, but you'll notice everything that gets returned is equal to false. So why is that the case? And that is this unusual feature that Numpy Nan, so the Nan is not equal to itself. So if you do the comparison operator and say, is this value equal to itself? Very strangely, you return a false. So that's one of the ways that you can actually recognize a Nan value, is that it has this unusual feature that it's not equal to itself. But Numpy provides functions that allow you to determine if it's Nan. So this isNan method function that's included in the Numpy module is used to determine, for example, if this is equal to Nan. So you can use it either on individual values or you can use it on arrays. So we can see what happens when we use it on an array. And so this is true, and this is true. So we can find all of the elements that are equal to Nan. And so we can send this to A using the slicing operator, and and then we return the 3 values that are equal to Nan. So make sure you always use isNan in order to make comparisons. And then if you want to do not, so these are all the elements that are true. And if you want to know all of the elements that are not Nan, then you have to, then the simplest way to do that is to use this tilde in front of it, and this tilde is the not operator in Numpy. And so all of the indices that are not equal to Nan are equal to true this way. So we can find all the valid data, doing something like this. And now we have the array of good data. So finally, one thing to cover with Nan is summary functions. So if you do summary functions on data that contains Nan, one thing to note is that if you ever just do like the mean of it, either using the built-in method or the Numpy, you receive a Nan value back. And so if you want, this usually is not very useful. Usually you want to take the mean, for example, of this array where you're excluding all of the Nan values. So there's a couple ways you can do this. You could do that. We saw how you can use this in order to return all of, oops, sorry, that's not right. We can use this in order to return all of the non-Nan data, but there's also these built-in functions like Nan mean, for example, and so you can simply use that, and so that it removes all of the Nan values for you before it calculates the mean, or like standard deviation. So there's a large number of functions that have this Nan version of that, so you just need to remember to use that whenever you have arrays that have Nan values within them.